Good morning. It's really good to be here with all of you. I was just thinking about this session and remembering my time at IIT Kharagpur where I was doing my bachelor's. I graduated in 1990. And I was thinking back about the state of technology at that time. And we didn't have any PCs or laptops. We didn't have Ethernet networks and Wi-Fi. We didn't have Google, Facebook, Amazon, WhatsApp. And I was discussing this with my son, and he said, "Dad, did you have TV back then?" And I'm like, geez, kids can be brutal. Of course we had TV. But we have come such a long way. We are talking about AI. I've had the good fortune of working with some of the largest customers around the world. Micron is one of only 3 companies that manufactures DRAM in the world. And memory is becoming extremely critical to AI systems, and I'll talk about that in a little bit. But we have had the good fortune to interact very closely with some of the biggest cloud companies, all of the device companies, whether it's laptops, PCs, servers, certainly smartphones, IoT companies, industrial companies, automotive companies, including EVs. And I just wanted to share a little bit of a perspective of what we are hearing from these customers worldwide about AI and their plans for AI going forward. So let's start with a very short video. So this video, and you saw that very nice music score. That music score was entirely generated by AI. And you see these images of these 2 individuals. They are not real people. They are people whose images have been 100% created by AI in an extraordinarily short period of time, just using text prompts. And this is just a tiny, tiny window of what is ahead in terms of that disruption for creative arts. I mean, a lot of times we think about AI, we think about logic, programming, all of these things, but AI is actually going to impact every aspect of life as we know it. And creativity is a huge thing that we associate with humanity, and you can see how easily just these early versions of generative AI are able to create all of these images within a matter of minutes, being completely lifelike. So what is happening in the world of artificial intelligence that is different today? People have been researching and making progress on AI for 3 decades, but something has changed. And let's talk a little bit about what has changed. First of all, the compute systems and subsystems, including memory and processor interaction, have radically changed and transformed. And I'll talk about that in a bit, but it is literally a step function improvement. We have been trying to learn about how the human brain thinks and create algorithms that mimic the thinking process of a human brain. And that continued for a number of decades. We created neural networks and deep learning networks. And really recently, in 2017, there was this breakthrough paper that spoke about generative AI and its capabilities. And generative AI focuses on taking in large amounts of data called large language models and predicting the next word in the sentence and using the context of the previous words in the sentences and paragraphs to predict that next word. And it was astonishing what that simplistic concept was able to create in terms of a step function in algorithms and learning. And we'll discuss that in a minute. But massive, massive data sets. You have seen these multi-trillion-dollar companies. Of course, they are hugely profitable, fast-growing companies, but it is also an important thing around data. And these companies have a really good moat around them based on the amount of data they have access to. So you look at Google with its indexed web and all of the photographs and videos from YouTube, they have that tranche of data. You have Microsoft with corporate data and applications. You have Facebook and Meta with social graph, Amazon with all the shopping data around the world, and you have companies like Tesla who have the biggest database of driving data from their cameras in the car. That is a critical asset. Now, for companies to compete with these giants, if you don't have access to large quantities of data, it becomes a very big challenge. So as you think about business plans, you have to figure out how to compensate for that. And then, of course, the connectivity in the world around us, whether it's Wi-Fi networks, LTE networks, etc. And when you pull all of these things together, a magic happens that has eluded us for a number of years and now has gone into really an overdrive. So as I started to think about, what are the most important trends in AI for our memory industry, for the technology business, I suddenly realized, and coming through from all of the discussions we have been having with our customers worldwide, that this is actually perhaps the most important trend for all of humanity. Because what this is going to describe is a trajectory that is going to impact every aspect of human life. And it starts with ANI, artificial narrow intelligence. A lot of what you see today, what you experience today, is ANI-based systems. All of the recommender systems, when you log on to your favorite streaming site, all of the recommendations that you get when you have your social feed in your favorite social program, all of that is artificial narrow intelligence. It's a very specific use case. But generative AI has changed that. Now you can see even people who were debating whether there will be artificial general intelligence, which is human-like intelligence, which means there is intuition, there is reasoning, there is understanding of psychology. All of these human-like traits, for the first time, now a generative AI system with a sufficiently large language model is able to create these capabilities. And you're seeing the very first signs of artificial general intelligence in today's ChatGPT-4 type of models, which are using approximately 1 trillion parameters. And I'll talk about a little bit more about the interaction between these parameters and how to get to artificial general intelligence. But even those who were debating that maybe we'll never get to artificial general intelligence, or maybe it'll be 50 years from now, there is a very real possibility that within the next decade, we will get to artificial general intelligence, perhaps even sooner than that, by the end of this decade. And that's a very big deal, because what comes next from there is artificial superintelligence, which means these systems are self-aware. And we talk about all of the wisdom, the cumulative wisdom of humanity in a data center. I'm not talking about all of the data in humanity or all of the knowledge even of humanity in a data center. I'm talking about all of the wisdom of humanity, which is a very high bar. And what you can imagine from there is you can have robots and you can have artificial capabilities that understand humanity in ways that perhaps even we don't understand it. So imagine having somebody, even though artificial, who is more supportive than your spouse, more empathetic than your doctor, more fun than your friend. And all of these things are not fiction because they are coming at us faster than we recognize. And some of these largest companies that we talk to are putting in plans in place to create so much compute capacity that it will dwarf the capability of us humans in terms of the cumulative intelligence present in these systems. So where is all of this going? I think these systems will have many, many world-changing applications. Autonomous driving is just one important one. 1.2 million people die around the world in road accidents every single year. 1.2 million people around the world. Now, autonomous driving can dramatically cut that down. Most estimates are for those numbers to go down by 80% once they are deployed in any given region. In that region, the number of deaths can decline by 80%. A lot of very complex models for climate and natural disaster prediction. But even for productivity in the workplace, many of you are either working in programming, have companies that have programmers that are part of the team. And there was a very recent experiment with the Copilot that Microsoft is now starting to offer for programming. And these Copilots, there was an experiment done. They took two groups of programmers. One group had access to a Copilot that was driven with generative AI capabilities, and the other group was just by themselves. And they found that the productivity of the programmers went up by 2x when using a Copilot, using generative AI. And as programmers became more proficient in writing the prompt, which, as you know, a lot of prompt engineering is critical here, the efficiency went up in some of the expert programmers to 4x and 5x of their productivity, which is, if you think about it, a very mind-boggling field. And not only is it a mind-boggling feat, but also they have now demonstrated, and you can test it out, I have done so myself personally, you can write entire programs, compile them, run them, debug them, rerun them till you get a result that you expect, purely with English prompts, with absolutely no knowledge of programming whatsoever. Zero knowledge of programming. And so imagine the idea of where all of that will take us from a productivity perspective. But just based on giving you a little bit of insight into what some of the latest trends are on healthcare and what is possible, I thought I would just start by looking at 3D structures of proteins. And proteins, obviously amino acids being the building block of proteins, and polypeptide chains adding up to create proteins. And these proteins are obviously responsible for every important basic function in the human body. And when we look at these proteins, it's critical to understand the 3D structures of these proteins, because that's what's important in discovery of drugs and advancement of human care and even understanding of diseases. And so far, out of 200 million plus proteins out there from all living things, we have had a database of 3D structures of proteins only for about 200,000 of them. And researchers started to use AI to figure out how to make this better, how to improve on it. And Google's AlphaFold was able to study the structures of 100,000 of these 200,000 proteins and predict the 3D structures of the remaining proteins. So it got to a database in 2022, early 2022, of 1 million proteins from 200,000. And within 6 months, it was able to predict the 3D structure of proteins of 200 million plus proteins that is going to really accelerate drug discovery across a whole host of diseases by many, many years. And this is just one example of the use of AI that we don't get visibility to every day, but it's happening behind the scenes. Something that is more, I would say, in the foreground has been what happened with COVID and the whole vaccine development timeline. And two critical technologies came together, mRNA technology and AI capabilities, and they resulted in an improvement in vaccine discovery and approval. Of course, the approval was a lot coming from push from regulatory bodies around the world. But a typical 10 to 15 year timeline, 4 years being the fastest that any previous vaccine had ever been approved in the world, was cut down to less than a year for COVID. Again, another example of what is possible with these technologies. But what I feel is even more interesting is cancer, which impacts every country around the world. Everyone has seen the impacts of this in either their family or their friend circle. The use of AI in cancer detection is extraordinarily inspiring. And there was a fascinating experiment conducted in one of the most prestigious hospitals in the US, where instead of training programs to understand what to look for in terms of a scan to assess cancer risk in patients, instead of teaching the AI program what exactly to look for, they fed the AI program hundreds of thousands of scans of cancer patients and hundreds of thousands of scans of patients who did not have cancer, and allowed the program to figure out on its own what to look for and to give some kind of a view of whether a new scan has cancer risk. And essentially, when they first ran this program, and they were giving obviously human feedback into the program, they came across a scan of a lady who had just come to the hospital that day for a routine exam. And the radiologist looked at the scan, everything was clean, and the AI program said, recommend immediate biopsy. 2 other radiologists then looked at that scan, and that scan seemed completely fine to them, and they tried to give negative feedback into the program that it needs to adjust its parameters. 6 months later, that lady came back with cancer. And at that point, they realized, when it started happening more, that these programs were seeing something in the scans that a human eye was not able to see, which is a fascinating milestone in itself. And not only that, but these scans were becoming extraordinarily effective in predicting risk of developing cancer within 5 years at a rate that was 3x better than human radiologists in terms of determining that risk accurately. And in a study published just last week, there is now a 10-second recording that people can make on their smartphone, and the risk or whether the person has type 2 diabetes or not can be determined by the AI software simply by listening to a 10-second clip of a person's voice, with the same accuracy as an overnight fasting blood glucose test. And this is just a mind-boggling milestone, because now it is clear that some of these AI capabilities are able to detect things in human voice that are imperceptible to the human ear, detect things that human eyes cannot see. And so that's where AI technology is going. And what this means to healthcare around the world is just fascinating because there is a global shortage of doctors, of specialists. Even in the Bay Area in California, where I live, sometimes when you need to see a specialist, you have to wait for a month and a half, really long waits. But with the use of AI as an adjunct capability, diagnosis can be done, differential diagnoses can be accelerated. Rare diseases, which take about 3 to 5 years to properly get diagnosed, can now get diagnosed within a few short months because AI software is so much dramatically better at detecting differential diagnosis use cases than human doctors can ever be. And so a huge possibility here to improve healthcare for the masses by deploying these systems. Obviously, these systems have to be tuned for every country, every background, but huge possibilities here on the healthcare front. I'll just touch upon a little bit in terms of education. Huge shortage of education teachers around the world. 44 million teachers shortage globally, which is a really challenging prospect because 1.4 billion people in the world don't have access to, whether adults or children, don't have access to adequate educational resources. And here, there have been programs that have been proven to provide really important supportive feedback to students, very empathetic and supportive approaches, very customized to a student's own learning capabilities. And here for countries, especially a country like India, the prospect for being able to do this is transformational for the education system. That possibility is really key. So I'll just touch upon a couple of other important things in terms of the use of memory in AI models. Really exponential growth of memory because these models are using these large language models to become smarter, become better, and the use of memory in these models is skyrocketing. But what's interesting is when the memory usage skyrockets, so does the capability of these models. So on the y-axis, you have the capability of these models to understand English prompts, and they actually go up with the size of the model. So that's why the size of these training models are so critical in this situation. And the legacy architectures are changing very rapidly. You see GPUs coming into the picture. These graphics processors are critical. The high bandwidth memory next to them is critical. And that's the whole processor memory interface that is driving these models to become so much more sophisticated. Micron has a really strong portfolio here. I won't, in the interest of time, go into all of that. But we're also using AI across our company to do a lot more than just develop products. We are actually using it to make our company more efficient, ramp yields in our manufacturing fabs, improve software programming capabilities, and such. A quick profile of our company, very, very patent heavy. We have contributed 54,000 plus patents, and we have 3,000 plus people here in Hyderabad and Bangalore, but very exciting for our new manufacturing facility in Gujarat, which is going to be the largest semiconductor investment in India's history so far, $2.75 billion. Thank you. We are super excited about this. This is going to make India a real global hub for manufacturing, and this is a great, great start, and we are super excited. So I'll just end with this slide. Lots of challenges ahead to deploy AI. It's not going to be easy. I think society is going to face a number of critical questions that will need to be answered. Each regulatory organization Each country will have to answer some of these questions, and they're going to really challenge the notion of what is the place of AI in society and how best to address some of these critical issues. Because of time limitations, I'm not able to go into these, but every one of these issues are super complex to solve, but it'll take a lot of resolve for us to be able to come together to solve them. With that, I'll take your leave. Thank you for your time.